From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. It's just me, Aaron, this week. How is everyone doing? We have two just great guests this week. And first one is Farah, and second we have Kilton, both co-founders at Edgeworks. We'll kind of do introductions individually here for a second. Farah, why don't you go ahead and start? Quick introduction, and then also I have a question, a VC question to ask you as well, but go ahead.
Sure. So as you mentioned, I'm a VC turned entrepreneur. I've been a VC for a number of years, always focusing on early stage, always looking for great technical guys like Kilton. My focus has always been on finding brilliant technologists because, I think the team is always the most important in building these great companies. And then helping them with the product vision, product fit, and helping get the company off the ground before I do the early stage investment. But in the case of Kilton, I was so taken by what he had already built. And, I believe in the edge as a thesis that I actually quit my job, just made partner, and joined up and started this company with Kilton about a year ago. So we're happy to be here.
Fantastic. And so I have to ask you real quickly as well. As I understand it, you were involved with SolidFire in the very early days. Is that correct?
That is true. Yep.
So you were involved in the super early parts, and I was involved in the end parts. So I did a couple years and got acquired by NetApp, and did a couple years at NetApp, and now I'm off doing the next thing as well. So maybe I have to say thank you.
You're welcome. It was a great investment. We were there on the first seed stage, and again, that's kind of been my model, is to find really, really, really great tech companies and then help get them started off the ground. And you're welcome about NetApp. I did help talk to them about making that acquisition happen, so I'm really glad that you enjoyed it.
Fantastic. So, Kilton, why don't you tell us a little bit about yourself and a little bit more of, what you've been doing and the problems you're trying to solve, and maybe a little bit more as to why Farah, quit her day job and decided to join you as well, right?
Sure. Yeah. So to give the brief history, I've been a techie my whole life. I started programming when I was 7 or 8 years old on a Commodore 64, and it wasn't long after that I was writing in machine language, which is kind of the equivalent of assembly for the Commodore, and got into digital electronics. And so this IoT era is kind of my era. We have this proliferation of a lot of different processor types and stuff. So I'm just having a blast. But I moved from Chicago to the San Francisco Bay Area in 2014, and I took up a pro bono role with the city of San Francisco to help out with evaluating IoT technology opportunities. And everything that came in our door, from big companies and small companies, all had the same problems. There's no real secure way to be running software in the physical world, and no way to manage it, and so on. And so after seeing the same problem again and again, I just struck out on my own and said, you know what, I'm gonna go ahead and solve this. And that's kind of how this all started. And that was 2014. And a couple of years into it, having figured out kind of what architecture seemed like it was going to work for the world, started to get some traction in terms of usage of the tech. And that's when I met Farah. And so it's just the time is actually really right. When you look all around, you're seeing edge this and fog this and whatever. The reasons are that we're actually starting to make use of these deluges of data, and folks are realizing, sending a terabyte of data over the internet when you don't have to is, really kind of silly from cost, perspective and latency. So there's a whole bunch of reasons to be at the edge. And now is just a time that I think everyone's waking up to the extension of the internet down into the physical space. And so we're having fun with it because it kind of vindicates all these years of effort.
Yeah. That makes perfect sense. And so tell us a little bit more about Edgeworks specifically then, because, obviously a new venture, as far as I can tell, kind of, maybe just out of stealth, if I could use maybe that terminology. Maybe y'all can help me out with exactly how far along you are in the journey here. Yeah,
so, that's a great question. So Kilton's actually been building for the edge before it was even called that. So he's been building a product since 2014, and we've gone through multiple iterations of it. In 2016, it was open sourced by the Eclipse Foundation. So it's been around. People have actually been using it, but it's kind of been sort of like I guess you would say stealthy in the sense that, we haven't really put the word out. We're actually launching the product this year, launching ourselves as a company this summer. So we're actually coming out of stealth in that way. From what we're trying to do standpoint, as Kilton mentioned, there's the edge is a real big focus nowadays. People are really looking towards it. I read recently that Microsoft is putting in $5 billion over the next 4 years. And what really differentiates what we're trying to do here is, if you look closely at a lot of these edge companies, they still are really closely tied to the cloud, in that even if you take a look at somebody like Amazon, Particle, Microsoft, a lot of the real actual data processing happens actually back in the cloud. So they're allow you to do some sort of analytics processing or some minimal processing in the case of Lambda scripts at the edge, but the real meats of it still goes back to the cloud. And we believe that's not going to be the path forward. And what we really want to do is focus on can you really run real meaningful software at the edge. So that's kind of what our thesis is. Alongside that, we want to make it so that we democratize it, that you don't really have to learn a new SDK, you don't have to learn a new programming model, you don't have to learn a new framework. You can take the tools that you already have, you can take software that you've already written, you can take best-in-class software like TensorFlow and others and run it at the edge without having to repurpose it. We have to rebuild it, re-architect it for the edge. So that's what we're trying to do, so people can actually build for the edge today. Like you say, we want to make it building for the edge as easy as building for the cloud.
Yep, and that makes perfect sense. And let's also maybe dig into definitions a little bit more, because I feel like too, when we first started this podcast years ago, you always had to, when we were talking to guests and we were talking about cloud, we had to define cloud. And I feel like when we're talking about edge, we need to define edge, because there's multiple ways, there's multiple layers, there's multiple definitions, and
absolutely.
And so there's a post, and I'll put it in the show notes as well. There's almost multiple layers to edge. In this instance, maybe there's 4 layers of device, gateway, processing, cluster, and cloud. Meaning, okay, that device is the physical hardware, but then you've got to get that hardware somewhere. You have to do, like you were saying, the processing on it somewhere. But then when you do the processing somewhere, you've got the data halls back and forth. You've got the latency of getting the data there to getting the processing and getting it back. Tell us a little bit more about how you envision the layers and architecture working.
Well, I'm glad you asked that question. And I think you might be referencing that Stacey that had in our article, the multiple layers of edge, which actually is it was actually a slide we created for a pitch deck that we shared with her, because we wanted to get more specific about how we define the edge. And Kilton, why don't you actually answer this question, because you do such a good job of it?
Sure. It's very similar to the list that you just gave, Aaron. So the device itself is, you could call that kind of like the extreme edge, because it's the source of data. There's no more edgy than that, right? Because it's pinpointed. And then the immediate layer above it is, we like to call it the enabling layer. So one of the things that separates the kind of like the full production scale world of IoT from the kind of the R&D or the makerspace version is, when you don't really care that much about board cost and you've got Wi-Fi everywhere in your home office, you can use a prototyping board that talks directly to some cloud and Wi-Fi, but you're not going to do that in production in a 10,000 square foot factory or warehouse. You just simply don't have the reach, the connectivity, or the battery life on things that you're deploying in mass quantities. So this enabling layer is the gateway layer, and it's where you transfer between like low power wireless to your standard internet connectivity or network connectivity. So basically, how would you go from like Bluetooth Low Energy or Zigbee or LoRaWAN and turn that into regular TCP/IP, Ethernet connection? That's that gateway layer. And so it enables. And that's for us where the magic of the processing starts. And then above that, you called it like processing centers. We call it micro data center in our description. And this is like probably on premise, but it is not physically located where the devices are. So it can't do the low power wireless. Bluetooth has got a range of 10 meters or 30 feet. Bluetooth 5 is better, but still, you can't be in some back closet in the center of the building and talk to the stuff in the room, in the patient care room of the hospital or right where the work's being done in the factory. And then above that, of course, is then cloud, which is central. We all know what that is. So down on this enabling layer where we do the conversion, the reason why we focus there is the devices themselves, they can have intelligence and probably should. Why would you report any data if it's not new? So if the temperature has been exactly the same for the past 10 minutes, maybe just send it when it changes. This is great use of device intelligence. But our intelligence is on that gateway layer because it's the first chance you have to process more than one data source. It's the absolute first stop for aggregate data processing. And it's also your last chance to add context. So when you think about it, once you're off that factory floor and away from the machine, do you know where the data source is? And if the device can only report, 4 bytes, and that's, a high precision temperature reading, how do you add that context about which device it is and what machine it's attached to? So you really need this enabling gateway layer to be far more intelligent than a lot of folks have thought about it in prior years. And that's magic for us, and that's why we focus there. We run equally well up in the processing center or the microdata center and up in the cloud, but very few other technologies run really well in the gateway. So that's where we focus on making our magic happen.
Yeah, that makes sense. And so if I pick it apart even a little bit further, I'm trying to now take that, what are those definitions, and apply it to what I've seen about EdgeWorks so far. So if I understand this correctly, then, the problem you're trying to solve is at the gateway layer, first of all, and then it is how are you trying to interconnect or provide value at that gateway layer? Is that a kind of a correct assessment of it? And then maybe also explain just a little bit more about that source and the problem of latency and like you were saying, context, right? Adding how important it is to add context in as well. So if you could maybe connect those dots just a little bit more for us.
Sure, happy to. So first on the value add, it's even more than that. If you can interconnect devices, you get the opportunity to actually provide the value across devices that everyone's been looking for. For example, I know to slow the speed of the assembly line motor because I'm detecting that the weight is too light on the filled boxes, and therefore we just automatically adjust, right? This is called operational technology, OT. The problem with OT translating to IoT is that it's usually closed and you can't do anything with that data upstream. So with our stuff, you're able to do those interconnects and make use of the data. So it's more than just interconnecting. It's actually providing interoperability, doing data ingestion, making secure connections to devices, and then also enabling you to actually do the processing right there. So that's where that kind of latency comes in. The latency over a serial port, a wired serial port from a piece of machinery to the gateway is very, very low. You're within cable distance. And you can take advantage of that to do some really fast turnaround processing, enable you to do real-time analytics or just command and control kind of stuff for and operational technology, OT stuff for something like a shop floor. And then above that, though, you have now merged that device into the enterprise spread, the enterprise scale system. So it's something more than just providing a connectivity for a device. You add context here. So I'm going to give you an example. If you were to take a pressure sensor that is used to determine how much material is loaded onto a pallet, for example, and you take that reading, and that reading is a 4-byte number, and it's high precision, you need to start adding stuff to it immediately in order to make it valuable in the bigger system. What pallet number is that? What factory are we even in? And what material are we trying to measure? Who's the employee, or who are the employees on shift that are actually doing the work? How about timestamps? So when was this reading taken, and so on? And all of these things are contexts that are very difficult for inexpensive, lightweight, and battery-powered devices to transmit, because if 4 bytes is used to send the pressure, you need another 4 to send an accurate timestamp. And so you essentially double your data transmission required to put that context on the device. And now how about the ID on the pallet? Do you think that device should be flashed with the ID of the pallet? Probably not, because if you got 10,000 of them, that's 10,000 devices getting flashed. I'd rather just slip them in the pallets and have the gateway layer do the context adding. So that's kind of what I mean by that.
Yeah, okay, I'm with you. And then so help me out then with when we're talking about like a platform layer or applications. Are we talking about full-blown applications? Are we talking about containers? Are we talking about microservices? Are we talking about unikernels? There's so many different ways to define, okay, if we define what edge means, there's also, you have to define what platform means. And so what is kind of your thoughts on platform in all of this?
So we kind of envision ourselves as being a horizontal platform for the edge. If you look at, the approach to IoT up until now, it's largely been solution specific, like, having kind of a solution for oil and gas, having a solution for, automotive and whatnot, for agriculture. And the challenge with that is, if you want to change your use case even a little bit, now you have to get in a whole new solution, right? So it's a very vertical way of thinking, and it creates these like silos at the edge, which is not the way we want to build for the future. So what we've done is we've provided a platform on which you can run any microservice. That what we can do is take applications, package them as microservice. They can be packaged as either Docker containers or as unikernels, and they can run at the edge. The beauty about this is that you can run any application. You can run application that if, for example, in oil and gas, if you've been building it for the last 10, 12 years, you've perfected it. You don't want to rewrite that for the edge. You can build that. You can take best-in-class software, things that people have already built. For example, TensorFlow, I mentioned earlier. We were able to package that in under an hour with entire neural net and run that at the edge. And then you can, again, build new software for the edge. And we have allowed people to do that on top of our core IOFog software that's actually been open sourced by the Eclipse Foundation. And we've already begun developing a microservice marketplace where people can develop any application that they so choose in any vertical. And you can go in there and just, take it down and use it today. So, and then on top of that, we as a company, in building this horizontal application, we're obviously making it such that people can build any application that they want on top of it. But as we go into these different industries, we start to see these patterns emerge of applications that people want to run. And so we've actually been working at building these, like, almost these bundle of suites, like an oil and gas suite, a telco suite, a surveillance suite, where we can sort of say, hey, we can take customer requirements and then sort of like generalize it so that people can then take what we've built and then sort of like customize it as they so choose. So there's a number of ways in which they can solve this problem. But to answer your question, we are a platform. We can run any application in the form of a microservice using the technologies of unikernel or Docker containers. Kilton, is there anything more you wanted to add on top of that?
No, I think you nailed that pretty well. Yeah, and I guess if you want to add a little bit more detail, how you make these things all work together is that you just use a set of local APIs as opposed to using any kind of a special library or SDK. So you can just kind of use the skills you've already got. If you're a C# developer, it works. If you're a Python developer, it works. Node.js, Java, and so on and so forth down the line. And we do that because if you have to pick up a new tool set in order to build for the edge, then you need to spend all your time getting ready to build and making your bet on that one platform as being the place where you're going to play. Or you spend all your time kind of recompiling or repackaging to try to make things compatible. And you really should just be able to drop it and go. And that's the promise of the cloud, right? Is you can basically write something and run it on any cloud platform. I don't know of any cloud platform that says no Python here. So why would the edge be any different?
Kilton, you have a great point there. And let me also add this, though. What is kind of, I'm thinking through my head of like, okay, what are the challenges here? And there's obviously always a number of challenges when it comes to edge and IoT, but which ones have, in your experience, have jumped out at you the most in these kinds of solutions? Is it the intermittent connectivity of IoT? Is it the low bandwidth? Is it the lack of repeatability that requires more of a platform kind of approach to solutions? Is it all of the above? What are the biggest challenges your customers have seen so far in your experience?
So it's definitely all of the above. And
of course.
When Farah and I get up and talk about how the edge is different from the cloud, the main factors are you've got power problems, right? Battery life and just lack of availability of power on the mains. And you have bandwidth problems, and you have intermittent connectivity, and you have big security problems. And all of this and more comes to the forefront. And the lack of repeatability is, I think, just like it was in the early days of the cloud architectures, It's just a matter of time before the best architectures start to settle in, and folks are finding, oh, it's far more repeatable than we thought. But the repeatability is more on approach than it is on, precise code reuse. We give you great code reuse, but you're still going to have to think through the architecture for each deploy. That's fine. Every application's got its attributes. But so in matters of like sparse connectivity and battery life and so on, yeah, this is the stuff that makes it so different handling the edge than handling like the data center or the cloud. And that's exactly why we exist. If you're solving these problems like the intermittent connectivity, if you're solving this problem on your own and rolling it in-house, then you're essentially solving the problems that we've been solving for the past couple of years. And we think we've done it pretty well. Why would you want to tackle that on your own again? We've done a ton of deploys to field test and so on. So you kind of have, this whole suite of issues that makes the edge so hard. And, security is one that I think a lot of folks think has not been handled very well yet, but we'd say actually to the contrary, it's something we've been focusing on for years. And happy to go more in depth on security, but I don't want to derail down into a security conversation. We can maybe get some more detail.
No, actually, that was going to be my next topic, because I was going to say, yeah, you mentioned the S word, security, and so let's actually talk about that, because our listeners maybe think of security, but they think of security in more of a cloud context, or more of in a virtualization context, or a very traditional enterprise data center context. What are some of the security challenges in IoT and edge at the larger level, and then more specifically, in the things you've implemented or seen in the past? What are the kind of very in the weeds security challenges that you're attempting to solve here as well?
One of the challenges in security, as you mentioned, is that people do think about it from a enterprise or cloud perspective. And for us, that's been a big opportunity, because we've actually thought about it from the ground up. Kilton, actually being an IoT director in San Francisco, actually has some great real-world example. And one, I think, is actually kind of a fun one that we'd like to share with you today as a jumping out point from how we think about security.
Yeah, there's so if you take the standard cloud security architecture, which is largely focused around PKI infrastructure, and then issuing keys out to things as equivalent to identities, trusted identities. If you take that and just put that out into the physical world, you run up against the kind of one of the primary problems of security at the edge. And the problem is that in cloud and data center stuff, you have physical protection of the compute. You're not able to just walk into a data center building and plug in a USB keyboard and mouse and get into the boxes there and start doing what you want. But at the edge, you are able to. And had this incident in the city of San Francisco with the SF Muni, and you have security credentials that are embedded into edge devices that sit on things like city buses. And well, somebody got their way in because essentially the keys to the house were left out there. And that's not bad-mouthing anybody there at City. This is the common practice of the day. And so this person who got in used it to, do all kinds of nasty stuff, shut down some of the gates and open some of the other ones. And they were asking for some Bitcoin. They got reverse hacked, because you should pick a different city other than San Francisco. Somebody got into their email and blocked them out, and it was just really funny ending for this poor schlub who tried to hack the city. But the point being, you can't take what works in the cloud and put it out in an environment where you don't have the same physical guardrails around all of your equipment that you normally have. You're going to end up with some really nasty scenarios. So you got to think differently about edge security. And the best way to think about that is, well, if I assume that everything that I put out there is going to be physically compromised, then what would the edge compute layer, the infrastructure layer, need to do in order to get ready for this? And that's stuff that we handle. And to get a little bit into the weeds, and you ask, like, so what, implementation-wise, what kind of stuff have we run up against? Well, how about something like this? First off, if you have to have a private key that you flash into every device that you put out there in your IoT deploy, and this is, by the way, this is Amazon's AWS IoT. This is their model, is that this is required. So first off, you're putting the keys to the kingdom out there, because when somebody gets that device and takes the private key, then they've got a trusted gateway into the back end. But also think about what it would take to flash 10,000 devices, each with their own unique private key, that is all done for you at operations time. That's a whole lot of labor in order to get your stuff out the door. So it just really doesn't hold at scale. But also, you don't want to leave those keys out there. So for us, it's all this. We've got this this dynamic mesh network so it's a software network that rides on top of connectivity. And everything that you plug in with us goes through a series of checks of the signatures that are all dynamically oriented. You don't have some baked-in private key that somebody can steal. You have what we call secure session through the entire software network. And that means that when something's physically compromised, we detect it and it gets quarantined. And so if somebody takes the box off the city bus when it's running EdgeWorks, the moment that it gets altered in any way, the signatures no longer match, and it's not allowed to transmit over the software network, but it's not removed either. It's quarantined. So we actually know someone's doing something, but it's not allowed to participate anymore in the data flow. And we shut down all the microservices and stuff immediately. And wipe off the data that's being held there. So you just got to think about Edge like, if I'm entering into a world that's really looks kind of Wild West, then shouldn't I be protecting myself from the ground up? And that's why we say the architecture has to be, Edge first. You can't think of it it can't be an afterthought. And that's what's led us to build what we've built.
Yeah, and go ahead, Farah.
I was going to say the old, just sum up the old model. What it does is actually increases our attack surface. And what we do with our software by adding this extra layer of security is we increase our defense surface, and that's what we're trying to do.
Yeah, and it is like you mentioned, Kilton, a completely different mindset, because I come from the you assume the device is safe context, and you're coming in from assume the device is compromised state. So no, I like that a lot. That's a great way to kind of eye-opening way to look at security with this. So it's very different.
Zero trust world out there.
Exactly. And between that and the differences as far as the multiple layers, it is a very different way to think about things, for sure. So we're running at our time here. So Farah and Kilton, where can everyone find out more about you, about EdgeWorks, and about anything you have coming up?
Well, you can go to our website, www.edgeworks.io. You can follow us at Twitter, at EdgeWorks.io. And you can go to the Eclipse IOFog site, www.iofog.org, where you can actually just download our software and start using it today. You can start using microservices that other people have developed. You can develop your own. And post them up in our marketplace. And at some point, you'll be able to monetize those microservices as well. So there's a number of ways you can actually get started using IOFog today.
Fantastic. Well, thank you very much, both of you, for your time. And on behalf of Brian, who wasn't able to make it this week, thank you, everyone, for listening. And we'll talk to you next week. Thanks, everyone.
Thanks, Aaron.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.